Today, I will discuss one more question from GCSE Combined Science Triology, Paper Code F, Foundation Tier, Chemistry Paper 1F, Thursday, 17th May 2018, morning paper. Question 5. So this question is on electrolysis. So a student investigates the mass of copper produced during electrolysis of copper chloride solution. From the figure also we can see that inert carbon has been used as an electrode and copper chloride solution is being used as an electrolyte. DC power supply is the power source. So yes, the question is, which gas is produced at the positive electrode, anode? So from the options, we can see that my answer will be chlorine over here. The reason being, over here, copper chloride has been used as an electrolyte and chlorine ions will be produced, which are the negatively charged ions. Thus, being negatively charged, they will be getting attracted towards the anode, and thus on the surface of the positive electrode, we will see the deposition of chlorine as chlorine gas. Today, I will discuss one more question from GCSE Combined Science Triology, Paper Code F, Foundation Tier, Question Paper 1F, Thursday, 17th May 2018, morning paper. So this question is based on an electrolysis setup. So a student investigates the mass of copper produced during electrolysis of copper chloride solution. So inert carbon electrode has been used as the electrode and copper chloride solution is the electrolyte. So over here, we are getting solid mass of copper. So the student has shown the following results in the form of a table. Time in minutes is been given in the extreme left and also has shown the mean copper produced after 1 minute from experiment 1, 2 and 3, which is 0.6. And after 2 minutes, it is from experiment 1, 2 and 3, the mean is 1.2. So over here, the question is, determine the mean mass of copper produced after 3 seconds. So since like the time is in 1 minute, 2 minutes, 4 minutes and 5 minutes. So over here, what we have to do, we simply just need to add the mean mass of copper produced in 1 minute, after 1 minute, which is 0.6 milligram, and after 2 minutes, like which is 1.2 milligram. So if we simply add it, we will get the answer as 1.8 milligram. The mean mass of copper produced after 3 minutes will be 1.8 milligram. One more question from GCSE Combined Science Triology, Paper Code F, Foundation Tier, Chemistry Paper 1F, Thursday, 17th May 2018, morning paper. So basically, a student does an investigation. Okay, try to find the mass of copper produced during electrolysis of a copper chloride solution. Inert carbon electrode has been used and copper chloride solution is the electrolyte. Because over here, we have to calculate the mass of X of copper produced in experiment 2 after 5 minutes. So over here, I just want to show the part of a table which will be very much relevant to us for this question, because I have not shown you the table over here. First of all, it is the time. So it's 5 minutes. This is my experiment 1, experiment 2, and experiment 3, and also the mean copper produced. This is the mean value. So after experiment 1, 3.02 grams of copper has been produced. Experiment 2, this is X. Experiment 3 is 3.01. And the mean value is also given, it's 3.06. Okay, so we have to find the value of this X. So how will we find it? So 3.02 plus X plus 3.01 upon 3, that is the mean of the masses of the copper obtained in experiment 1, 2 and 3 equals 3.06. So if we try to find the value, so it will be 6.03 plus X upon 3 equals to 3.06. So solving for X, 3.15 milligram. Today, I will discuss one more question from GCSE Combined Science Triology, paper code F, Foundation Tier, Chemistry paper 1F, Thursday, 17th May 2018 paper, morning time. My question is based on electrolysis. So over here, the student investigates the mass of copper produced during electrolysis of copper chloride solution. Okay, like the copper chloride solution used in the investigation contained 300 grams per decimeter cube of solid copper chloride solution dissolved in 1 decimeter cube of water. Okay, so this is my question, and the student used 50 centimeter cube of copper chloride solution in each experiment. So we have to calculate the mass of copper chloride using each experiment. So over here, what we can see that the units used are a bit different. So over here, one is my 1 decimeter cube of water, copper chloride dissolved. Another is in centimeter cube of copper chloride solution. So first we have to convert this. So if you want to convert my 50 centimeter cube to decimeter cube, we have to simply divide 50 upon 1000 equals to 0.05 decimeter cube. Okay, so this much volume of copper chloride solution. Okay, he used in each experiment. Okay, so now we have to find the mass of the solid copper chloride. To find that, we simply just need to multiply the 0.05 decimeter cube of copper chloride with 300 grams of solid copper that has been used. So if we multiply this to, we will get the answer as 15 gram. So yes, the mass of solid copper chloride used in each experiment will be my 15 grams. Today, I will discuss another question from GCSE Combined Science Triology, paper code F, Foundation Tier, Chemistry paper 1F, Thursday, 17th May 2018 morning paper. So this question is based on the figure where it's showing an apparatus which is used to investigate the effect of electricity on solid sodium chloride and molten sodium chloride. Okay, so now based on this, a statement and a reason has been also formed, and there is also table 1 which is telling us about the observations and deduction. So observation 1 is solid sodium chloride. Over here we can see both the setups are being used to check whether the bulb is glowing or not. So with solid sodium chloride, we can see the bulb is not glowing, and thus we can see that no current is being conducted to lighten up the filament of the bulb. But with the molten sodium chloride, we can say that the filament bulb has lightened up, and it means that the solution is conducting some electricity. So over here, we have to draw one line from each statement to the correct reason. So if my statement is like solid sodium chloride does not conduct electricity. So my answer, so there are 4 reasons given. The ions are fixed, the ions are mobile, the ions are neutral, the ions are vibrating. So since it is not conduct electricity, so definitely my answer will be ions are fixed. Because the ions are fixed, so no ions are free to move. So in this situation, no electricity is getting conducted. My next situation is molten sodium chloride conduct electricity. So over here, since the mobile ions or the ions which are moving, they will conduct electricity. So my answer for this will be this statement. The reason will be the ions are mobile, because the mobile ions will be help in conducting the electricity. Thank you so much.